G'day everyone, we're back with another functional programming challenge. Today is Thursday the 10th of January and we're going to jump into the Exercism elixir track. If we have a look here, we've got all of our completed lessons and today's challenge is Isogram. I've already loaded this up into VS Code, so we'll jump over there, take a look at the README and solve the problem. Isogram. Determine if a word or phrase is an isogram. An isogram, also known as a non-pattern word, is a word or phrase without a repeating letter. However, spaces and hyphens are allowed to appear multiple times. Examples of isograms: lumberjacks, background, downstream, 6-year-old. The word isograms, however, is not an isogram because the S repeats. Execute the tests with this. As anyone that's watched the stream before knows, I like to start off just by running the tests to make sure that the test file is named properly. That's totally fine. Let's have a look at the test file and see what sort of tests they're going to run later in the lesson. Isogram lowercase. Assert that subdermatoglyphic is an isogram, so I don't see any repeated letters in there, so that is an isogram. 11 is not an isogram because E repeats multiple times. Demonstrably, all in uppercase is also an isogram. Alphabet is not an isogram even in uppercase because the A repeats. This, I'm not going to count up the letters, but that looks like an isogram. And it says here that dashes are allowed to repeat, so we shouldn't treat the dash or the hyphen as a letter that repeats. I'm getting the impression that we should only be looking at the letters, so that's giving me a hint about something. Not an isogram, 25, E is repeating. Emily Jung Schwarzkopf is an isogram because the spaces don't count. So hyphens and spaces don't seem to count. The quick brown fox is not an isogram because O repeats. Let's jump into our isogram module and see what we need to implement. This is a fairly simple one. We only need to implement an isogram question mark function, which receives a sentence, which I can tell from the spec is a string, and what we need to return is a Boolean. So we need to determine if a word or a sentence is an isogram. Thinking about this problem, I think that probably one way to do it would be if we split each one of these phrases or words or sentences into the parts that make it up. For instance, if we take this one, and we were to split it up into a list, we made a list out of this, then we could remove all of the duplicate characters and compare it to the original list. Let's start building out a function that does something like that, just so we can have a play around and see where we get. So let's take the sentence, and what we'll do is we can split this up into its individual characters in a number of ways. One way is to use string.split, and if we just pass in an empty string to split it by, then that's going to split it up into its characters. I'm going to run back over to the test, go to the top, and grab out the line in the test file that allows us to load this into IEX, jump down into IEX, load the code, go back to Isogram. In the terminal, I'm going to load up the Isogram module and call the Isogram function there. And what I'll do is I'll pass in that first word that we have and see what it looks like when we split it. As you can see, that's split it up into its individual characters. One thing that I don't like is at the start and the beginning, there is an empty string. That's a side effect of splitting on an empty string because the start and the end of a string are also separate characters. There is a way to get by this, and that's to use the trim true option. Let's reload the code, run it again, and we can see that that's given us the list that we want. It's each letter in here split into an individual character and in a list. The other way that we could do this, if we jump back over to here, we could also do this with string.toCharList. Let's reload the code and take a look at what that does. So all that's done is it's actually split this into a char list, and you can see the difference because this is a single quotation mark versus a double quotation mark for a string. If we inspect this with io.inspect and we pass the option char lists as lists, we'll see that the actual underlying representation is a list of integers. So this string down here, which is not actually a string, it's a char list, is actually just a list full of integers. Both of these ways are totally fine. I think probably string.split is a little bit more clear. Performance-wise, I'm not 100% sure, but I think maybe char list may be more performant. For the purposes of a tutorial like this, it doesn't really matter. Now that we have it split up, what are we going to do? How would we determine whether or not a string has no repeated characters? Well, the one thing that I thought of when I first saw this is a function in Elixir in the enum module called unique. And there's no UE at the end, but it's uniq. And what this does is it takes in an enumerable, which is a map or a list or something like that, and removes all the duplicate elements. For instance, in the example here, we have enum.unique for 1, 2, 3, 3, 2, 1. And what we're left with is 1, 2, 3, because 3 repeats, 2 repeats, and 1 repeats. All of the duplicate elements are removed. What I'm thinking is, if we go back to VS Code, let me just make a little comment here. Let's say, for instance, we have a list of A, B, C, right? So if we had a string that got passed in of A, B, C, we could split it up into something like this. Of course, it would be strings. And then what if we had a list like A, B, C, C? If we split that up into a list, that would be A, B, C, C. And what we could do here is if we run that enum.unique on this list, what it will do is it will actually give us this list here. So the unique list is that one. And for this one, if we were to run enum.unique on this list, we would actually get the same list back, right? So what I'm thinking here is that if we have a list, if we split a string into a list, then run enum.unique and compare the lengths of the two lists that we get back, we'll be able to determine whether or not there's a repeated character. If there are no repeated characters, the length of the list after we've run enum.unique is going to be the same as the length before we ran it. If there's a duplicated character, no matter what the character is, right? If we add A to the end of this list, it's going to be the same thing. C and A are both going to be removed because only A, B, and C are unique. Either way, the original list is going to be longer than the second list, and all we need to compare is whether they're exactly the same. So what we can do here is let's set this to a variable, and what I'm going to call it string split. And that's just going to be our split string. What I'll do is I'll just pipe that to io.inspect. Let's reload the code in here, and we'll see what comes out when we run that. So there, we've just split our list, and that's our string split. What we can do now is we'll call this string split unique. And what we'll do is we'll pass the string.split to enum.unique. String split. And what I'll do here as well is I'll pipe that to io.inspect so we can examine the differences. I'll reload the code and run that function again. They look exactly the same. So this is the output from our io.inspect. They're both looking exactly the same, and that's because I don't think we have any repeated letters in there. Let's run it on a string that we know repeats. Let's look at our ABCCA string. Our first list there is just the string split, and the next one is the one with just the unique elements in it. And the lengths are different. So I think here what we'll be able to do is return whether or not they're the same. The way to get the length of a list in a functional programming language, that's usually might be a property of the list. In Elixir, there are two different ways. We can use kernel.length, or we can use enum.count. Excuse me, enum.count. Let's have a look at the documentation for both of those. Kernel.length, return the length of a list, allowed in guard tests, inlined by the compiler. And let's have a look at enum.count. Enum.count returns the size of an enumerable. They're both going to be exactly the same. Let's prove it. Kernel.length, and we'll pass in string split, and then we'll do enum.count, string split, and we'll just pipe those to io.inspect to see the output. reload the code in the terminal, and we'll run it again on ABCCA. And we can see that the length of our string split is 5. So that's our kernel.length, and this is our enum.count. They're both exactly the same. If we do the same thing for string split unique, let's see what comes up. Reload the code down in the terminal, run it again. And so here we have enum.count. I'm sorry, this is kernel.length, enum.count, kernel.length, enum.count. And we can see here that 5 is not equal to 3. Let's do it again for our one that we know is an isogram. And here we can see that both those counts, where previously we had 5 and 3, are both 17. So all we need to do here to actually give the correct output to determine whether or not something is an isogram is just compare kernel.length or enum.count for string split and the string split unique. If they are the same length, it means that there are no duplicated characters and it means that it's an isogram. If there are repeated characters, then the length of the string split unique is going to be less than. It's just going to be different. Let's reload the code and take a look at what comes out. This one returns true because those two are the same. Let's run it on our ABCCA, and that returns false. I think we should be able to pass most of the tests with this. I'm going to clean up the code a little bit, and then I'll run the tests against it to see how close we get to actually solving this problem. Let me just remove that. I'll jump down to the terminal, quit out of IEX, and run the tests. Cool, our first test is passing, and we're still printing something out. Let me just remove that for now. Run the tests again. Cool, our first test passes. Let's run back into the test. We'll comment out the next line to run the next test. This one is testing the word 11, which should return false because there's a repeated character of E. Cool, and we've passed that test. Uppercase. Now, since we're only comparing the lengths of two lists, when we split it out, it shouldn't actually matter about the case. All that matters is whether or not one of the characters in there is actually repeating. So one thing that I think may trip us up is if they pass us a mixed case where we have an uppercase A and a lowercase a, and we say that they're repeated. I didn't see that in the tests, but maybe we can do that as an extension. So let's run the tests again. Cool, that one's passing as well, as I expected. Let's test alphabet. This one has a repeated letter of A. That test also passes. Isogram with dash. I think this may trip us up. At the moment, we're just splitting the string and removing duplicates, and we're not doing any checking whether or not they're alphabetic characters or they also include dashes. I believe this test is going to pass. Let's take a look. Sorry, it won't pass. And we expected truthy, but got false. So this is an isogram, but we returned false because we have the repeated hyphens in there. I think the best way to do this is just to remove any non-alphabetic characters. For now, what I'm going to do is I'll leave that in there, but let's put an io.inspect here and an io.inspect here. And what we'll do is we'll jump back into IEX, load the code, and see if we can just remove non-alphabetic characters. I'll load the code, and let's start with a word that we know is an isogram, and we'll throw in 2 dashes and see what comes out. This is returning false, and the reason is that we've got 2 dashes in here, and if we compare it to our unique function, we can see that in here it's removed both of the dashes. And we don't really care about the dashes, so I think the best way to remove both of those is going to be with just a string.replace. What we'll do is we'll just, in the original string, this one, we're just going to remove any non-alphabetic characters. So in here, the way that we do that is with string.replace. Let's pull up the docs for string.replace. Returns a new string created by replacing occurrences of pattern in subject with the replacement. As you can see here, we have subject, pattern, replacement, and the options. The pattern may be a string, a regular expression, or a compiled pattern. Let's have a look as if we just pass in a string. So we can just pass in a string of dash, and this will replace all dashes, and let's choose what we want to replace it with. I'd like to replace it with an empty string. So let's reload the code and take a look at what that comes out as. So we haven't inspected. Let's inspect that string there again. This has made the test pass again. And you can see what's happened is that we've taken out the 2 hyphens in there and just replaced them with empty strings, which returns the string just to its original way. This will make our next test pass, but I can see that as soon as we have spaces in there, it's going to fail again. And really, it's not the dash specifically that we're concerned about, it's any non-alphabetic characters. The way that we can replace any non-alphabetic characters with something is by using a regular expression. In Elixir, we use the sigil R to show a regular expression. And if you're not familiar with regular expressions, I'm just going to put this in, and maybe I can give a tutorial about this later. But if we wanted to match any non-alphabetic characters, we'd open the square brackets and we do not A to Z. What this means is any character, this character means not, and then A to Z. So we're basically saying any character that's not A to Z, we want to select and we want to replace it with an empty string. This is going to fail on uppercase characters, and the way that we could include uppercase characters is by doing this. Or what we can do is put the I at the end of it, which makes it case insensitive. If we reload the code and run it again, we'll see that we've replaced the correct things. Let's throw in some spaces just to confirm. Cool. So that removes any non-alphabetic characters. We can also change one of these to uppercase, one of these to uppercase, and that's totally fine. We've just removed any non-alphabetic characters regardless of the case of the characters. And so now this should return our tests to a passing state. Let's quit out of there and run the tests again. And that passes. Let's run back to the tests and comment the next line. That passes too. Let's comment the next test and check if that passes. Cool, that passes as well. And the quick brown fox is not an isogram. We'll test that as well. Very nice. All our tests are passing. And what we can do now is clean it up and refactor. I'll remove the comments at the top as well. Let's have a look. Let's remove that, i.inspect, format the code. It's already formatted. Let's run the tests again to confirm everything's working and we don't have any warnings. Perfect. No tests failing and no warnings. Now I think here what we can do is I've spotted an easy way to trip us up here, because if we have something like this and if we write a new test, phrase is isogram. Let's see here. If we put a capital E here and we put an E at the end, that still counts as a repeated letter. Let's run that test. Oh. Phrase with uppercase and lowercase is isogram. What I've noticed here is that this will actually this should return true, right? But we have a repeated letter of E, and we're not doing any checking about whether or not it's uppercase or lowercase in the actual program file. And that has passed, and it shouldn't have passed, right? And so the reason that we have that is refute. This isn't an isogram because we have a repeated letter of E. Cool. Our functions return true for this one. And the reason that it's doing that, we can have a look at our function and see why. Let's load our code and let's replace this string with this one. And you can see that returns true. And the reason is that our unique list is actually going to treat the uppercase E and the lowercase e as being different characters, even though they're technically the same. Excuse me. And an easy way to get rid of this is to use a function called string.downcase, which will make all of the characters in the string the lowercase version. Let's do that in here, and we'll see what happens. String.downcase, We'll reload the code and run it again. And this time, we can see that instead of being an uppercase E at the beginning, string.downcase has turned it into a lowercase e, and the lowercase e at the end is still there. And then when we remove it in the unique one, we've actually got a list of a different length, so we return false. If we jump out of that, and we'll run the tests again to confirm that the new test that we added to it is also passing. Cool. Now all the tests are passing, even the one we included. The one thing that I think may cause some problems is if we, let's say we replace, let's see here. If we have, let's just make these strange characters. So all I've done there is Alt-A, which has added, I believe that's a Nordic character. This one should, let's copy that test rather than doing that one. So this one's good. We've passed that one. Let's paste that. We'll remove the duplicated E. And what we'll do is we'll replace this with a strange A character and another strange A character. Now this one should fail. And the reason is that in our string.replace, we've only got A to Z, and this isn't going to take into account any other characters. Let's run the tests, and we should fail that one. Excuse me, I haven't renamed it. Uppercase and lowercase strange character is isogram. Run the tests again. So we have one failure in there. Okay? So the reason is, if we run back into our IEX, let's load the code. And we'll load in that string that we've done in there. You'll notice that we actually chop out that character. So in here, between the J and the N, we should have that strange A character. And then in between the W and the R, we should also have that strange A character. So I think probably the better way to do something like this, since we only want to take a look at spaces and dashes, is instead of doing anything that's not alphanumeric, we match specifically on hyphens and spaces. So what I've done there, that represents a space character, and actually it should work without that, and that represents the hyphen character. Let's reload the code and check what comes out. Cool. So that's kept in our A character, and what it's done here is it's removed that second one. And all that we've done is we've just changed our regular expression, and actually since we're not matching on any characters anymore, we can just remove that I. And we can run that again to prove it. That strange A character is now not being removed because we're removing specifically spaces and dashes. And if we add a space or a dash in here, let's do that. Cool, we're removing spaces and dashes, and we can match specifically on the characters that are allowed to appear in the string that aren't alpha characters. Let's quit out of there, run the tests again, and we should still have everything passing. Great. We've added 2 tests in there just to make sure that our function is a little bit more robust. Once again, I'm going to remove these ir.inspects to get rid of that output in the tests, save it, format the code, run the tests again to confirm everything's passing and there are no warnings. Great. All the tests passing, no warnings. Exercism submit, and we're going to submit the Isogram module. Let's jump over into Exercism and take a look. Well done on solving this exercise. I'll mark it as complete, and I will share my solution with you at the end of this video. Awesome. There's my published solution. And thank you very much for watching. We'll be back tomorrow with another little coding challenge on Exercism in the Elixir functional programming language. See you tomorrow, and thank you for watching.